Started with, let me check some lights here. Is that a little better? Is it too bright? If we have the light on, there, it doesn't look too bad. Okay, so day 2, we're going to simplify radical fractions, rationalizing, and complex conjugates or conjugates. Okay, so remember our properties of square roots. You can break apart square roots through multiplication, but you can also break apart square roots through division. So you can take a fraction and just square root the top and then square root the bottom. Let me zoom in a little bit. So you can square root the top and then you can square root the bottom. Okay? Okay, so let's get started right away. So simplify the expression. Well, you can square root the top. The square root of 25 is 5. And you can square root the bottom is 8. So the square root of 64 is 8. So 5/8 is your final answer. We always talk about not using decimals for these. Try and use as many fractions as you can. Okay? So using our prior knowledge of 9-1, day 1, 6 is not a perfect square. So we're going to leave that. So we've got negative root 6 over square root of 49 is 7. Okay. Break apart your numerator and denominator and just treat them separate. So the square root of 100 is 10. And then remember, with powers and letters, you just have to take the power and divide it by 2. So 6 divided by 2 is 3. So that's x cubed over 5y. Root 25 is 5, and the square root of y squared is y. 2m to the 5th. So in the numerator, I've got root 2. Well, actually, what we want to do is we can cancel before. So my bad. This problem is designed to have us cancel. So underneath the root, I can cancel first. So 2 and 98 reduce to 1 over 49. So I just cut them in half. And I have 5 m's on the top and 3 m's on the bottom. That leaves me with 2 m's on the top. So then we can square root the top and the bottom. Square root of 1 is 1, and the square root of m squared is m. And the square root of 49 is 7. So that simplifies to m over 7. What if the bottom number is not perfect? There is a rule in math that says you can never have a radical in the denominator. It's an old-fashioned rule that somebody came up with a long time ago, and they came up with this thing, so thus you have to get it out of the denominator or on the bottom. This process is called rationalizing. So whenever I do my little fancy trick, it's going to be called rationalizing the denominator. Okay? Might zoom in a little bit, maybe. There we go. So what does it mean to rationalize? I say it's a rewrite. So if we had our calculator, and we'll do this in class, but if you take 1 and divide it by the square root of 3, and then I'm going to find its alternate form. I'll show you how to do it, which is root 3 over 3. If you take these two and type them in your calculator, you will get the same decimal. It's because they're the same. One just looks different. One has a radical in the bottom, and you're not supposed to have that. So somebody a long time ago said, no, can't do that. You got to write it like this. So we're going to practice taking these and writing them like that. Okay? There's a neat little trick. It's a shortcut. I don't know exactly how other teachers teach it. It's probably not the perfect method, but I'm all about giving you guys shortcuts so you have an advantage in the future. All you have to do is take the radical and put it in the numerator. So you have 9 radical 11. Then in the denominator, drop the radical. Now they're the same. So 9 divided by the root 11 is the same as 9 root 11 divided by 11. It's kind of slick, okay? When you're done, though, we just have to make sure everything's in lowest terms. So is 9 and 11 in lowest terms? It is. Root 11 is in lowest terms, and it is. Let's do the next one. So we're just going to rewrite it. We're going to take the 5. So in the numerator has 20 root 5, and the denominator has a 5. Okay? Then I have to simplify. 20 divided by 5 is 4. So anything on the outside that doesn't have a root is normal math. So 20 divided by 5 is 4. So the answer is 4 root 5. So this one, I'm going to take the radical and put it in the numerator. So that's 3 root 6 divided by 7 times, and drop the radical, 6. Now we got to simplify it. So 3 root 6 in the numerator, 7 times 6 in the denominator is 42. Now does 3 go into 42? You know, if you have a calculator, you can take your calculator and do 3 divided by 42, math fraction, and it will reduce it for you. If you need to see that again in class, email me or ask me again in class, but you should know that 3 goes into 42 14 times anyways. So when you reduce it to lowest terms, it's root 6 over 14. And now it's done. So let me circle my answers so you guys can find them in the video. Sorry, I did over here, 5/8, negative 6/7, 10x cubed over 5y, and m over 7. All right, page 2. This is going kind of quick. So we'll see how this page goes. You've got some radicals here to simplify. So you should always simplify a radical before you try and get rid of it. Because if I bring the 27x squared up here, it's not in lowest terms, and it's going to make it way too big and way too complicated. So let's simplify it first. So let's just work with the denominator. Okay, so I have 3x over 27 can be written as 9 root 9 times root 3 times root x squared. So you just split them all apart. That's what we learned how to do in day 1. Now we make everything simple. Root 9 is 3, so I've got 3x over 3. So the square root of 9 is 3. Square root x squared is x. And then I still have the root 3 in the bottom. So I simplified it. I'm not supposed to have this root down here, but I can simplify before first, right? The word simplify means make more simple. So you've heard me say this in class. If you haven't had me in class before, right? If I owed you $8 and then I owed you $2, why would I go get $8 and then go get $2 more when I can just give you $10? Because 10 is more simple than 8 plus 2. So taking something and then timesing by 3x and then dividing by 3x, I might as well just cancel them. So I'm left with 1 over root 3. Now take the root 3 and do our little rationalizing trick. You just bring the root to the top and then drop the root in the bottom. So there's your answer. Okay? All right, last one. It looks like I've got roots everywhere. I can simplify my root first. So in the numerator, I've got root 4 times root 3. And in the denominator, I've got root 5n squared. So what did I do? I broke the 12 as 4 times 3, and I canceled an n out of each numerator and denominator. I can do that as long as I'm under my root. Okay, so now let's simplify everything. That's perfect. Square root of 4 is 2, so I have 2 root 3 in the numerator. And in the denominator, the n comes out. So what's the square root of n squared is n. So I've got an n root 5. Okay? Now, let's do our trick. Let's bring the root 5 to the numerator. So this becomes 2 root 15 over, and then you can just drop the square root in the denominator, and that becomes 5n. So that's our little shortcut for square roots. I make it look easy. Your algebra teachers always make it look easy. This is not easy, guys. So keep working hard. Keep doing your basic math skills. Watch the videos as many times as you can to help you. Ask your teachers for help too, okay? All right. So now we only have a radical in the denominator, but we have a plus minus sign as well. So it can be positive, it can be negative. How do you get the radical out of the denominator now? So basically what we're saying is you have a minus sign, and all the other problems we just had a radical. Now you have a minus sign. So in the world of fractions, you can't treat fractions like normal when you have pluses and minuses in the bottom. So for example, if I did 7 plus 5 divided by 6 in the numerator, right, I can just add the 7 plus 5, or the 7, let me do a better number. Let me do 12 and 6. How about that? So it makes it a little bit easier, right? So if I went this way, 12 plus 6 is 18. 18 divided by 6 is 3. I could also go this way and split my fraction and go 12 divided by 6 is 2, plus 6 divided by 6 is 1, and I could get 3 that way. You can't do that when the denominator has a subtraction sign. So for example, if I switched it, right? If I did 3 over 6 minus 9, okay? I can't go 3 6 and then minus 3 ninths. It just doesn't work that way. The math doesn't add up, okay? Because I would have 1/2 minus 1/3, which is not, if I did it the other way, I just get 3 over negative 3. I don't get the same answer. So you can't just split your square root. So you can't just go 7 over 2 and 7 over root 3, okay? So the trick is to, instead of just moving, what you do is you move the bottom to the top, but you change the sign. So instead of 2 minus root 3, we're going to do 2 plus root 3. And then in the bottom over here, we're going to do 2 plus root 3. And now we got to multiply them together, okay? So in the numerator, I've got 7 times that. So that's 14 plus 7 root 3. I just did the distributive property. We taught you how to multiply in day 1. Now in the bottom, look what I get. I get 2 times 2 is 4. And then I get 2 plus root 3. Then I get negative 2 root 3. And then I get a positive times a negative is a negative, and root 3 times root 3 is 3. So my numerator is 14 plus 7 root 3, and my denominator, the roots cancel, and I'm just left with 4 minus 3 is 1. So that's called rationalizing the denominator. It's called the conjugate. Oh, I see that word on the front page. So that's called the conjugate. It just means multiply the top and bottom by the opposite. Only change the middle sign. So here we go. Let's do, it looks like we got 4 of them to practice. They're all the same. That's kind of the nice thing about it. So my denominator is root 5 plus 1. So I'm going to multiply the numerator by root 5 minus 1. And the denominator by root 5 minus 1. So what do I get in the numerator? 2 times root 5 is 2 root 5. 2 times negative 1 is minus 2. So that's my numerator. Okay? Watch how the denominator works. Remember I told you foil, 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 foil. It's never flu, flu. You got to do the outers and the inners. This one is actually flu. You can get rid of the O and the I, okay? It's just a shortcut. The O and the I will always cancel out. So it's flu, unless we got something fancy where we may have to go outers and inners, but we'll check that later. Right now, we're just going to go root 5 times root 5 is 5. Okay. Well, they will cancel. And then 1 times -1 is -1. And we got to clean it up. So we have 2 root 5. Well, hold on. Why do I always multiply the numerator? I'm going to keep the numerator the same. So cross that off. Let's rewrite the numerator as 2 root 5 minus 1. My bad. I don't want to jump to conclusions and multiply too fast because we can always simplify. So my numerator, so let's write that out. My numerator is 2 root 5 minus 1, and 5 minus 1 is 4. Sorry, I'll let you catch up. My bad. You can pause it. And then 2 divided by 4 is 1/2. So there's a 2 on the bottom. So the answer is root 5 minus 1 all over 2. Look at my steps, a lot of steps. There's the work step, multiply. There's a lot of things going on. So make sure you're paying attention to your accuracy and your calculations. Okay? All right, 11. We're going to multiply the top by 1 minus root 5 and the bottom by 1 minus root 5. So I'm going to leave my numerator the same just in case. I can simplify 1 minus root 5. But in the denominator, I'm going to flu it. 1 times 1 is 1. And a positive times a negative works like this every time is a negative. And then root 5 times root 5 is 5. And it looks like nothing can cancel. So my numerator is root 13 minus root 13 times 5 is 65 all over -4. Now typically you don't ever have a negative in the bottom of a fraction. I won't mark you down, but that probably should go out in front. It just looks weird to me in the bottom of a fraction, but I'm a math teacher. Okay, let's do another one. I encourage you to pause any time during the video and try a problem yourself, okay? All right, so I'm going to multiply the top and bottom by 10 plus root 3 over 10 plus root 3. So I'm going to keep the numerator the same. That's root 6 parenthesis 10 plus root 3. And I'm going to flip the denominator. 10 times 10 is 100 minus root 3 times root 3 is 3. Notice I'm going to circle my answer there. Notice the root is now gone, so I can clean up my numerator and my denominator a little bit. I wonder, distributing and making it more work. So if we did this, root 6, 10 plus root 3 over 97, we could be done, but here's the deal, right? You guys are freshmen. But at some point, you're going to take the PSAT and the SAT. Let's say we looked at that, and that wasn't one of our choices. Well, then we would need to distribute the root 6. So we would have 10 root 6 plus root 18 all over 97. And then we go look for that answer, and we're like, oh, I don't see that one. Well, it's because root 18 is not in lowest terms. That's 3 root 2. So 10 root 6 plus 3 root 2 over 97. That also could be an answer. Depends on if the question asker wants you to distribute that or not. Right, if we look over here, we could have left it as this as well because it's not really factorable anyways. But either way is fine. Okay, but you got to get the bottoms right. It's 97. Okay, 2 radicals in the bottom doesn't matter. as long as you know how to do your conjugate. So you're going to multiply by root 3 minus root 5 all over root 3 minus root 5. So the numerator is, we might as well multiply that out. That's root 15 minus 5, because root 5 times root 5. And then let's do flu in the denominator. Root 3 times root 3 is 3. Minus is always a minus when we do conjugates, because a positive times a negative is a negative. Root 5 times root 5 is 5. Clean up my denominator, that's negative 2. So we're going to have root 15 minus 5 over 2, and it's negative, so it should be negative 2. Typically, we put our negatives out in front. But if there's a negative in the bottom as multiple choice, you just pick it. Okay? All right. Day 3 coming up. I think that's it. Yep, day 2 was done. So nice job, guys.